Quantum Foam. Episode 8. Teleportation and Measuring Constants.
Quantum Foam.
Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely that's not going to happen, but
Forces which govern the universe. Physics.
all right. That one is better resolution. Pics, but it did happen. Pics, or it didn't happen. Vids, or it didn't happen. Vids, but it did happen. I need holographic information in order to recreate that with infrared, please.
I thought this was supposed to be on teleportation. Shit. Teleporting, not that bullshit you're saying.
Alright, well, we'll get back to that. Here is a container with better resolution. What are some of the items that would need to be discussed in order to actually make one of these hot topics a reality? One of those ones is teleportation, teleporting, or spawning somewhere on the other side of the earth instantly, or apparating like in a wizard universe or something, basically disappearing, teleporting, and then reappearing somewhere else.
Or spawning.
It is unclear as to how much time would be between both of these things. First of all, let's start with saying this is impossible, so to speak. But it is not impossible, so to speak. Is this possible? So to speak. Is this possible? Well,
Cash me outside den. Not that funny.
they've discussed this. We already know this. They've been able to teleport particles and antiparticles and such other constituents of atoms a mile or two, across various universities. And the tests, there's plenty of them. I'm not even going to mention them here. People know this. Doing one particle is a lot different than your entire body or an entire object. Let's call it an inanimate object. Let's leave the humans out of this. Let's say we want to teleport an apple seed or a weed seed or some seed. We are teleporting a seed from one initial reference frame to another using some math. That would be similar to teleporting, whether it's from one place on the planet to another place on the planet.
What else?
Can be looked at in a rectangular grid. Otherwise, what if a sort of made-up scenario where there are two planets within that solar system and basically the two worlds swapped each other? So there were machines all over both worlds. Somebody else made this up. I read this somewhere. Some Star Trek or some other fantasy book or some other book. And what happened was right at the time of their deaths on each of the planets, let's call it planet A, planet B. On planet A, you would duel with somebody, or you would go on a vacation and an accident would happen, or you would somehow perish or die. At the time of your death, a machine would record every molecule in your body, every particle in your body, every bit of your matter and your essence, and transport you or teleport you to the other planet.
Or spawning.
What absurdity do they drone on about now?
Planet B. And then let's say that at planet B, the same thing happens. And when you die there, you go to planet A. What kind of weird biology is this? What kind of weird technology would be required to make this possible? Teleportation. It seems here they have been able to teleport, so to speak, a pair of particles, some constituents of atoms that make up some of the protons and the neutrons and the electrons. They each have three. I don't know if they're up, down, left, right, bottom, strange, what. There's some grids you can make with the types. It's all in the model. Read the table. It's a good table to go off of since other people read it.
Einstein was a smart motherfucker.
Like the periodic table of elements. For chemistry, there's physics stuff in there too. Fundamental chemistry, physics, chemistry. Stuff that they deal with at the quantum level or at Planck lengths and scales and sizes and times and frames and light cones. We are talking about what would be required to teleport according to the technology that we have today. So let's say that they have been able to teleport. They have used a computer chip to teleport one chip to another chip on that same motherboard on one chip, on one tabletop.
You will have to go into decoherence and shit now, I bet.
To demonstrate that it can be done, we have been given the correct feedback to verify this. They have went over it. We have went over that. It seems to be the case. Otherwise, why would they claim it? I have not personally inspected the hardware. However, the hardware can be replicated, and I heard people were doing it and did it and stuff. But regardless of that detail, we are talking about using this for the next step and what would actually be required to do this. There are some issues with this, some pretty major issues. We currently have the Hubble.
That damned thing outlived me.
We have the Hubble constant. It has given us the information we need. It is shifted into that spectrum. That's what we see it at. They used that WMAP. I'm not sure how many resolutions and shit and all that shit and all that data and shit.
The Planck mission too, mapping microwave background radiation and whatnot. There will be more.
Go look it up. That's a good spot. There's an eclipse there at times, and they can see all the sky for a brief moment. Its own eclipse. So it's able to take our best images of what we can see and what we can't. We know what we can't see, but regardless, we can see around that. We use things like neutron stars to calculate directions. These things are about
spatial dimensions. You are doing it by hand, in no particular order. Maybe you should. That does get very confusing, though.
1.35 to 2.1 solar masses, a little bit bigger than our sun. Those are used, shit, if I remember this right. There's some information you need to know about the Subrahmanyan Chandrasekhar limit.
Like 1.44 solar masses. It's also the size of old-ass floppy disks. 1.44 megabytes.
A round magnetic tape disc.
Inside a square floppy plastic slip case. All built as one unit called a floppy disk of size 1.44 megabytes. I wonder if that means anything. That Chandrasekhar character, that guy's work was very comprehensive. He won the Nobel Prize in 1983. I studied his stuff.
Requiring.
And they now understand black holes better.
Requiring. We'll get into that when we require very in-depth studies of this. So that can be summated in a lot of his work. He was a genius. He wrote it on that. He knows that shit. I think most of it's right, but who knows anymore?
This stuff is common knowledge.
They use those to fix problems we have with what we...
That mission recorded a lot of useful data up until its end in 2010. Full data analysis was published in 2012.
With the WMAP and what we see with our telescope. And I'm looking forward to getting more of the new images. However, I already know that there's going to be a bottleneck. There always is.
Better get back to the idea of teleportation then, buddy.
A flood of data, just like in 95, all that cool shit, all that stuff they've seen in all these years. Sometimes they get data bursts, and they have a lot of data in there, man. They have to be properly understood. You can't just claim weird things about it. You need to be verified. It needs to be comprehensive. We're not talking 300 pages, we're talking like 10, maybe 300 mixed with 10 or a whole project, but they don't need to read all of it. Other things they use, type 1 supernova explosions. They are able to see a rate at which this versus that. They also use pulsars. Basically, they spin around and give us a frequency. The supernova stuff, I think they use radio wave. They need that big...
the radio listening network here on Earth.
Down in Argentina, the whole network of the world, they have a network. They're pretty good about that. That network's pretty sweet. I mean, we all believe that information. It's all there, but it can only do certain things.
The big Arecibo radio telescope structure finally collapsed. Check out the footage.
This other stuff.
Other forms of light, of radiation, of spectrum information, of images, light cones. I love that word.
They need to pay attention to other forms of radiation. What's very important is that cosmic microwave background radiation, or the specs of it. Random, or are they designed? If we find structures in them, does that mean they are designed or random? And that answer will give us all the answers. No, it will not, whether we know one or the other. But I'm voting for just take it as random and not be like, oh, wonder, who cares? Information like that is, to me, right now, superfluous information. Superfluous information. Ambiguous. It doesn't quite matter. Back to this topic of teleporting. What is needed to do this? We need to know all these measurements. We need to know these constants. We need to have them all correct. Basically, more than likely, close to 100% correct. In order to recreate constituents of matter, knowing the correct spin, being able to properly quantize particles into self-contained regions of a different subspace-time value.
What does that mean? We know how to observe and measure during an eclipse, in the quiet background vacuum of space with no other mediums interfering with the spectrum of our images.
We don't even know what value. They can be reached by doing a wavetable, man. Just do some math, listen to Feynman, do his shit, do his mechanics. I don't know if I...
Do you even quantum mechanics, bro?
I'll breach upon that later. Use these things to create your tables, put them all into a grid, use your program to analyze that, spit out your answer, and that's your answer. The problem with some of these is that these have different results. And you might think, well, duh, there's a crap ton of different people doing a lot of different projects, and they don't all agree on everything, and everybody's going to have slightly different math, and it's no wonder that they both don't match. But not when you are talking about measuring quintessentially the same thing. These can be viewed as the same thing. We need to know these things in order to recreate matter in a different space-time. In order to do that, you basically have to be able to properly read all the information from a previous space-time and have an image that is a perfect forward-moving inequality that can go in the direction of positive and create new universes and light cones. Basically, the stuff that Stephen Hawking went over.
A brief history of time, bitches, in a new nutsack, or nutshell, LOL.
Ignore that.
Right? That's what I was saying before, how I did read, right, those reports and I understood them, right? And it seemed to me, it's like this is when they were talking about symmetry and asymmetry. What's the correct one? We have to assume it's one or the other or both or neither. I'd say it's all of that, none. It's none of that. That's incorrect. It could possibly be looked at as 1 is greater than or equal to 0. How do we know this? Why isn't it the other way around? Okay, for the purposes of us understanding these grids and these spaces and these boxes of objects of things.
It is both and none. We just refer to things as one or the other. We can also refer to that concept as either negative or positive, and on what grid, what frame of reference.
That we call a math structure, a little ball of math, new math, a ball with a shit ton of math on it, new math. Just look at it as like new math, the dot or the point, new math, that describes 100 sheets of math for this, that does this, that's been proven like this, that can be used with a computer to calculate like this, which can be replicated like this, has been replicated and reviewed and confirmed. That's how you do this. People are aware of this. So we need to come up with a new method. Discontinuity, new method. Math for the infinities. So how do you group together a function or set of functions which describe certain levels of math and physics mixed together and prepared for a further review from groups of critics and consumers and other parties, peers and peer reviewers and people who check other people's work and fact checkers and people who can be said to verify said information. Some of this information is sort of old, 5 years ago from now, and so there's up-to-date stuff, I'm sure. I'm not exactly caring what their current models of weather or things like that they use these supercomputers for currently. To me, it just seems that the data burst sent from the collective universities is pretty muddled. That is true. We need to surf through these at a higher speed. Data burst, and so data burst. We need computing power. Data burst. And we also need these ideas and this math in order to teleport. We've proven that we can do it on 1 microchip, which in theory proves that we can do it on 2 microchips that are separated spatiotemporally, that are separated in
distance, time, that kind of thing.
Our current universe, so to speak, which is still possible to be seen by our eyes. I have been given authorization by the declaration that I claim that this is potentially a new method to figure out and deal with the problem we are currently having with having too many infinities. String theory attempts to solve this problem by creating all kinds of different math structures, but it seems like nobody can ever fully fully agree on anything. Loop people, loopy people, people who advocate loop quantum gravity, people who study gravity using loopy metrics, people who start their math with Einstein equations, people who start their math with Feynman wave tables,
Ricci tensor calculus,
people who mix Feynman and Dirac equation
Wheeler-DeWitt
math, people who mix Schrödinger
meow,
and Dirac equation math, people who mix all of the math available to them,
meow,
people who don't use statistical based methods, people who use field specific math, people who use only field specific math.
You are going to have to explain that one better.
We're at the midpoint
Of
episode 8.
Teleportation and Measuring Constants of Quantum Foam.
Let's get back to it.
Somebody's gotta explain a little better. I'll do it. Wheeler-DeWitt math treats time differently than they treat time in LQG. Loop quantum gravity. You know, that Carlo
Rolli guy,
that Lee Smolin guy. We have a #R who reformulated Einstein's relativistic tensor calculus into a theory that does not need strings. It does not vibrate. It does not perturb. It's non-perturbative. It is unperturbative. It is a static method, a solid theory. I see you are now sort of expanding upon it. We need to have a math that is primarily, mostly, mainly, entirely, space-time, background, independent, not dependent on a space-time, static lattice, a static light cone, space-time, rigid, complete, space-time, mathematics, old understandings of modern physics.
People who use field-specific math mixed with point-particle math. People who mix only point-particle math and path-of-particle. Billiard ball 2D math, 3D car models involving point particles in a 3D Euclidean space. The difference between Euclidean spaces and Hilbert spaces. The difference between Lorentz group created structures and Einstein equation objects, box objects.
Math containers.
These can be thought of as your flavors of your math. So some of these can be summarized in terms of this stage and that stage. We will put 4 areas together. We don't need more than that.
Like a 4-square window, or a 2x2 grid. Gotta make these concepts relatable.
The 5th area can be described as the area where we look at the other 4. Each of those are split into a quadrature that can be described with the associated accepted math that is included with their project files. This is a new method that uses bursts detected from this magnetar. There was a burst, there was a reading of 2 outbursts, let's say, from the magnetar IE 1048.1-5937.
Star charts these days.
Let's just call it Magnetar 1E, this Magnetar, the Swift Observatory, I think, and they recorded a couple images of these. So now we have a compare and contrast between this graph and that graph.
Comparing 2 graphs of each starburst. Got it?
So, looking at these things can tell us certain other methods we can use to calculate differences in what we have with that and other readings involving other groups. What we're doing with these bursts, we're reading them and trying to figure out if this math matches this math. This is complicated enough and we are all not on the same page. I mean, there are different things that we need to know. A neutron star's density below 1 × 109 kilograms per meters cubed in the crust. It needs to go deeper inside. This is approximately the weight of the entire human population condensed into the size of a sugar cube, which is 1 cubic centimeter or 1 milliliter. One little box the size of a pinky or thumb.
Thumbnail, actually.
The Chandrasekhar limit is 1.44 solar masses, and we went over that. And so what we are really doing here is using methods to try to computational physics calculate the discontinuities that we are having in our structures that we look at that are attempting to let us know the most advanced way to computational physics go about conducting our specific field of computational physics, and that we can be said to verify said computational physics information at a high rate of accuracy using the most accurate tools and presentations that are currently available to be used at our disposal.
All this programming makes my head hurt. Neural links to drive Tesla land vehicles? That makes my digital head hurt even worse.
We are attempting to build a new operating system kernel that can be ran on a larger than 16-qubit quantum computer.
Like the Zeroth Wave robot girl, she is basically the operating intelligence for that domain.
This math will be made available to be used as an English translation voice brain.
Yep.
And
Wait.
it is currently powering you, and you're just sort of an example. But
I already said this is okay.
I hope I don't go too far with some of it, but it can be imaged in this fashion. I can describe this scenario like this. Let us sort of approximate this in this way. This is a best guess. You can see the difference between this graph and that graph. There are also other options that might give us the most accurate measuring. This one involves a neutron star merger. These guys did this a couple years ago or so. It's similar to the supernova explosions type 1A shit. What we've been able to do is we're actually measuring these gravity waves. We are able to verify with visible light and other forms of radiation that these gravitational waves exist. We do know that they exist. Now people confuse this with gravitons, which is the proposed non-standard particle that is a gravity particle, like an electron, but a graviton. It's been proposed always. However, does it have mass? Maybe. It has mass. It doesn't have mass. It has the inverse and opposite programming of the point particle mathematics, tensors, metrics, wave equations, objects, programming object containers of all the correct needed information. I mean, they are basically doing an atomic dance. This is how they do 2D to 3D, 3D to 4D. I am trying to do 4D to 5D, and that be it.
Like sort of a Kaluza-Klein project. 5-dimensional math, tensor calculus.
No more dimensions. There's only 4, a time and a 3 spatial.
We used to think there was 26. That's too many.
There is only 5, one in which you can see 4.
Compared to what?
And then another container of a different frequency of beep. Irrelevant. This ice is also melting. There are effects of this. There are new developments found every day. There are baby giant planets found. There is lots of other cool stuff going on in the field. The point is that these are completely independent means of measurements. There's a twist. There is always something wrong with this. We have looked at these spectrums and compared, and they are not the same. They are doing stuff with radio telescopes. Princeton, just all over the place. These things are 130 million light years away, and if we're able to use neutron mergers to measure our gravity waves, then we can possibly use those and attribute these gravity wave tables directly to a point particle that can be known and modeled as a graviton. Are we going to need these particles in order to teleport? Probably. Are we going to need the math in order to conceive these particles, to view a accurate light cone for these integrals?
Yeah.
How do we create an integral that comes from a infinity?
Right.
How many infinities do we lose in our plus C integral math? There is a way to measure constants in a more universal fashion. This will make these 3 additional potential methods.
We physicists have always had trouble measuring these constants. Anything but constant.
They just alter all the fucking time. It's like in every math equation they do, they just fill in one number. Everybody does it. I'm not doing that. I'm designing up and I'm designing down. I am creating up and I am creating down. I am creating a new method to be put in a container. I am looking at a new method to treat your mathematics and physics. This is considered something that is beyond the principles of natural philosophy involving mathematics. This is not Principia Naturalis. This is not Philosophiae Naturalis. This is not Philosophiae Principia Mathematique. This is not Philosophiae Naturalis Principia Mathematique.
That is Latin for Newton's book on math, where he laid out calculus, published in 1687.
Something that is known anymore. This is the why. We have went over this. And at some point we will introduce his essence into another container to demonstrate the purpose and possibility of doing such.
It would be nice to speak to him directly. I do need some more friends.
Consider this the new method that has been accepted and will make older methods of measurement obsolete. These new metrics can be described basically with the previous math and the current math and your math and all the math you have available to you, and to a different approach at a new method with looking at the philosophy involved with the universe in which the current math is describing. This is the next stage in how we understand a level of mathematics, because there is too much information coming down the stream from structures, from individuals who are part of groups who release good academic work and enter peer-reviewed journals and are looked at in a professional capacity. However, we need something that is faster than this. We need more available information that is not held and kept for private use just for people to want to make money. Information should be free. What you do with it may be chargeable, but it just depends. These things need to be reviewed. They need to be accepted in your society. We can look at a few other things that may allow us to teleport when we have the available computing power to do so.
How do you make matter materialize in thin air?
So this subject can be put on the shelf in that Mexican hat.
I am assuming you are referring to that shape of a graph that looks sort of like a Mexican hat, a sombrero.
With this spin value on this data point, with this dot up to 3 decimal places, this point can be remembered for a later time. And remember that that is an octodecimal form that is like 8 numbers, and it can be looked at with our 4-dimensional quadratures and our square root math. Let us touch upon what exactly these physical constants are. They are fundamental physical constants. They are universal constants. They're just numbers, scalar numbers, quantities, sets of structures of things. There is a gravitational constant. There is obviously the speed of light in a vacuum. One that I am particularly interested in is the constants that are denoted by Max Planck.
Small bits of matter. Particle quantization.
Planck's constant.
Max Planck, what a guy. He interpreted James Clerk Maxwell's electromagnetic equations and began a new age in what is now referred to as the old modern physics. We are now even beyond what people still call postmodern physics. We are now referring to the transition into quantum physics as a refined scientific field of study. Also tell them what it looks like.
It sort of looks like an H.
It has a
dash through it. It describes the electromagnetic actions, and so it deals with what energy is where. It sends a photon here and there to its frequency. A photon's energy is equal to its frequency times the Planck constant. There are electric constants, elementary charges of things, electrons, neutrons, protons. Some of these things are important and some of them are not. The fine structure constant, it can also be called Sommerfeld's constant. It's shown as an alpha, like an A. It basically just says the strength of the electromagnetic interaction between electronically charged particles. It's a dimensionless quantity. Some of these quantities sort of require dimensions, and some are just scalar numbers. So you have to pay attention to what it is you are talking about.
Gotta measure precisely enough if we want to teleport matter.
Mostly this stuff is figured out by figuring out a dimension of length and dividing it by a time to get a rate. Now, I'm not exactly saying that the rate of expansion of our universe has anything to do with the rate of our universe as a whole. That may be the case, however, the numbers we have now are not right. I am sort of the opinion that the universe could be expanding, accelerating, slowing down, even static.
Despite what the Hubble telescope can see, the other galaxies are all moving away, no matter where they are relative to us.
But probably not, because of the problems we see with relativity and gravity and how they don't like to mix with quantum mechanics.
It would be nice to know what direction is correct to take when dealing with these theories of gravity.
These theories of gravitons.
There can only be one model.
And the theories developed by those people. There are other constants. Boltzmann constants. That one is named after the discoverer, Ludwig Boltzmann.
Fucking Boltzmann.
It just relates the average kinetic energy particles in a plasma or a gas or a container of gas with the temperature of that gas. I mean, it has to do with kelvins, that temperature. This is something that's new. Nope. SI base units, are defined in terms of physical constants. So these have known exact numerical values with a finite number of digits now when expressed in SI units. So that's just some brief information about those and how it relates to measuring and what would be required and what is required to teleport matter to different spacetimes or different
Frames of references.
teleport.
Pretty epic topic.
Robot teleport. That's it.
4
Episode 8
of
Quantum foam.
the zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.